And again, in my test folder, I have my belly pan. Let's open her up. This is going to be a lot of the same stuff again. All right. So we've got to go around. We've got to figure out how to do everything here. So we're going to short circuit some of this stuff because it would take a long time to actually do this and set it all up, but we're going to do quite a bit of it. So design wise, we're going to go into manufacturing again. Okay. Sure you select manufacturing. We go into our setups, new setup. Now, this time what we're going to be doing is taking a flat piece of sheet metal, right? Like big piece of sheet metal here, and we're going to be mounting it down on our Velox CNC and going around it. Okay, so just have that image in your mind as we're doing this. We are probably going to also mill out the exact dimensions of this within that piece. So let me show you how we're going to do this. Don't worry about machine setup, milling. Orientation, we're going to keep this orientation of X, Y, and Z, but we're going to move our box point to this bottom left-hand corner, okay? So again, we're going to start milling from down in this area, right? The body we already have selected. We're going to go over here to our offsets. This is where I'm going to add, I'm just going to do this kind of indiscriminately at 1 inch, and the top offset I'm going to leave at 0, okay? So what this means is when we were choosing the thickness of this in Onshape, I believe it is 0.09 inches that we selected. So 0.09 inches thickness for our aluminum, we would want to make sure we had a piece of aluminum that was that thickness, and then we would leave our top offset as Z, right? So when we're doing sheet metal, we want to CAD the same thickness as what we actually have in real life, right? So we would go over and find a piece of sheet metal, figure out that depth, and then notice our Z height here is 0.09. So that's exactly what we have, all right? And we go from there. All right, so what this means is we have a piece of sheet metal that's actually bigger than our belly pan. So we got to get, somehow we got to actually get this milled out of that piece of sheet metal. So we're not going to be perfectly in the center. So when we start our X, Y, and Z, it's going to be at the edge of the sheet metal down here, but our actual belly pan is going to be interior to it. Okay, perfect. All right, so we put our sheet metal down, we find our edges, and now we need to pick one of the operations to do. You can start with any of the holes. Usually, again, I tend to pick the smallest hole first and put in my smallest bit first and go around and do all those holes, all right? There's other ways of doing it too. For example, maybe you want to do the holes first so that you can go back and put in wood screws into those so that you can hold that piece of sheet metal down better, okay? Which is a good strategy as well. So we're going to do these rivet holes first. And rivet holes we already know how to do, right? Pretty easy. We're going to do our boring operation. We're going to go in our select from our Velox library, a 1/8 inch flat end mill. Okay, so Velox library, 1/8 inch flat end mill, select. All of these feeds and speeds come in, woohoo! Then we go to our geometry, and we're going to select one hole here. Doesn't matter which one of these we select. You can select any of them. We're going to do the same diameter. Now, we don't have to worry about Z height here because we don't have a tube. We don't have another plane to work off of. So we can just leave it, and this is fine, okay? Now, our heights, we may want to go a little bit below again. So I'm going to put in negative 0.02. So that's our 20,000ths of an inch again. We're going to leave all of our passes, and stock to leave. We're just going to leave. We're going to have it take everything out again, okay, and keep going. And then our linking is fine. So we hit OK. I'm going to zoom out. Now this is a much longer operation, as you can imagine, because we've got all of these holes to do all the way around it, right? So if you look over here, it says T2, and then it says 15 minutes and 14 seconds. Let me go back over here. sidebar. I'm just going to pull up the sidebar at the same time, and you'll notice my tabs up here. So I've got my belly pan and then I've got my sidebar. Along all of our operations here, I forgot to mention, you can see it's 53 seconds for this one. It's 25 seconds. By and large, your longest operation here is going to be changing your tools out, okay, and finding your edges and flipping it over and doing your mounting. The time it takes to actually do these holes is pretty trivial, okay? But then when we get to the belly pan, takes some serious time. You're going to put this down. You're going to let it sit and run for 15 minutes to make all of these holes. All right. Now, still a lot faster than if you had to manually drill all these holes, right? But it's a lot longer than what we had for the tubing. Okay, so now we have all of our holes done around the outside. Now, if we needed to use those holes to actually hold our piece of aluminum down at that point, we could do that. Okay. I'll get into work holding, by the way, more when we actually are at the shop holding down a piece of aluminum and we get creative in how we do that. All right. Okay, so we have our boring operation done. Now we need to go to some of our other operations. So to do these holes, we treat them the same way and these areas the same way that we did our bearing holes. Okay, we're going to take those out using a pocket operation. Okay. We have our 1/8 inch. We're going to want to take out more and we're going to want to do it faster. Now you may say, but that's great, coach, except these smaller holes here, you're not going to be able to do them. You're correct. This is one of the downsides to the way we actually set up our Swiss cheesing of the belly pan. We may actually not do those smaller areas at all. We may get to this point and say, you know what? Even though on our CAD diagram we had these, we're actually not going to take out these small slices at all. We're just going to leave those small slices in our aluminum, and we're only going to take out the larger holes or something that's, you know, maybe as much of a half circle or more. Okay. We can select them at this point. It's completely discretionary. Now, here's where it gets long and tedious, right? We have a lot of holes here to do. So we would go through and literally select each one of these. And again, you have to be precise. You have to select the bottom of these, otherwise it does not do these correctly, okay? I may say, oh, that's a big enough hole, and this is a big enough hole, but this one over here is getting pretty small, and so on. And then I just move around. I can also do this square area as well, okay? Now, larger area like this, I'm actually probably not going to do it that way. We're only going to do our circles or partial circles in a pocketing operation, all right? And some machinists might not even do these that way, but generally speaking, I see them being done this way. So we'll use the pocketing operation for just our holes. Now, as we're going here, at any time we could stop and take a look at it and come back in and add more holes to it, right? Now, the reason to do that is your machine might really start cranking on these. Now, okay, so let's just say I've got 19 of these selected. Let's do an even 20 here. Okay, 20 selected. Let's go through the rest. Our heights, again, we want to be at -0.02. So we're going to take it down just a little bit. But say, you know what, we're pretty precise here and we don't want to chew up our wasteboard very much. We can take that down to just 0.010 of an inch if we want to, okay? Now, if we find after the first cut that it's not going down far enough and not cutting everything out, you can stop it, come back in here, adjust this one parameter, re-export it, and run it again. And you'll find that when you're doing these things, it takes iterations, okay? So it's not uncommon for us to do it multiple times. All right, we're going to leave these the same. Now, this is not important to have these Swiss cheese holes precise. So we're not going to leave any stock to leave on them, okay? And then our linking, we can just leave the way it is. I'm going to click OK. Now, it's going to, oh, it didn't take too long. It took about 20, or it just took a couple seconds on my machine. Depending on how old your machine is, it can start taking a while to calculate some of these things. But it takes 28 minutes for the machine to actually mill all of these out, okay? If we had a laser cutting machine that was powerful enough to do aluminum, this would be much faster, okay? CNC machines are a little bit slower for this type of operation than a laser would be for cutting these, okay? And I believe where we had these done before, they used a laser to do our belly pans. The laser also is fast at doing these smaller ones, and you don't have to switch out tools with a laser, which is kind of nice. You just have a laser. So, okay, let's talk about, so you could go around here and select all these holes. I'm not going to continue selecting them, but we would obviously do that if we were doing this on our final belly pan, okay? Now we want to do, let's say we want to do these pockets here for our gearboxes. Okay, so these are holes for our gearboxes. How do we do these fairly quickly? What I would probably do is I would literally, we know where this is located on our piece of aluminum. I would take a drill, I would go over and grab a drill from the shop. I would put in a drill bit, and I would drill 2 holes in the center of this to hold the stock down, okay? Then I would put a wood screw in both those holes to hold down the very center of this piece here. I would do that on both sides, okay? This is going to speed things up so that you don't have to mill it out using a pocket, and it takes a ton of time to do this. So let me demonstrate this for a second. I can do a pocket, and if I were doing this the old way, 1/8 inch end mill, same feeds and speeds, I'm going to select this as a pocket, and it's going to go around and do this. Where I'll do it even and put our depth in, -0.1 of an inch, 0.100 of an inch, and I'm gonna not leave any stock. Okay, this, again, we're horseshoes and hand grenades when we cut out our gearbox holes, so we don't have to be as precise as a bearing hole, so we can do the 0 stock to leave. By the way, leaving stock also leaves a better finish. So if you want a better finish on it, not just a more precise finish, but a better finish, then you do the stock to leave, okay? Okay, so it does this, and it takes 14 minutes to do this one hole and etch out all that aluminum out of it, okay? Let's do something different. Let's go up here instead, and I've drilled my, so say I've drilled my 2 holes in this with my regular old shop drill. Instead, I'm going to go around and just do my 2D contour around the outside of it. So I choose my 1/8 inch. I do my same feeds and speeds. I go in here and I select my contour. And then I select my height, -0.01 for 0.100 of an inch. We're going to leave these the same, and again, no stock to leave, okay? And I'm going to click OK. Now, all it's going to do is go down, and it's going to go around this once. It takes 1 minute and 31 seconds. So notice, just by going over there, drilling 2 holes and putting 2 wood screws in to hold the center, because again, this is the same thing as that puck operation, right? It's going to leave that square in the center. It's going to leave that square in the center, and we don't want that just flying out all over the place and hitting our bit. That's why we're going to drill 2 holes in it, hold it down, and then go around the contour of it and get the rest of the hole taken care of. Okay, any questions about that? Okay, hopefully when I go and actually demonstrate this, because I'm going to do a session where I demonstrate doing this, I'll remember to do something like this so that you see how we actually set it up on the CNC. Okay. All right, so that's how, so this pocket operation, you can just leave it. By the way, you can move these around on the side. You can decide, you know what, I want these boring operations to happen after my pocketing operation, so I'll just move it down to the bottom, or move it after this and move it around. So you can move these operations around. This last pocketing operation, I may never do, so I drag it down to the end and I just leave it. I may put it down here at the end and just, sometimes I put ZZ in front of it as, hey, yeah, I did this, I want to save it, but I'm not really going to use it. That way I have it there for reference in case I need it. There's just different tips and tricks you can use for doing this stuff. Anyway, or you can just get rid of it, right? I was just demonstrating it so you can get rid of that particular operation and it's gone. Then we're back to our normal operations. I'm going to move this one up We do our boring, then we do our pocketing, and then we do our contours. Oh, I thought I changed this. Okay, well, we can change it now. Different tool sizes, right? For some reason, this is the 1/8. I want this to be our 3/8. Go from there. That should be okay, okay, and then it changes. Okay. Oh, it actually took out less at a time. Notice it's jumped to 35 minutes. It was at less. Give me a second here and I'll show you what happened. 3/8 of an inch again. I know what happened. Okay, we must not have this set up quite right on our 1/8 of an inch because this is doing a little bit smaller. Here's what's happening. If you notice, as this spirals in, it's much smaller than we did the 1/8 of an inch. We're doing more passes around and around and around in this than we were doing with our 1/8 inch. So let's go in here and take a look. This is happening, I want to say, because of our maximum step over. Give me 1 second. I'm going to change this to literally 10 times more. I'm going to take that 0 out and hit OK. Look at that. Now I have, it only goes around 4 times and it's done with the hole. Okay. Why is this? So my 1/8 of an inch, I don't think is set correctly. I'm going to have to go in and double check what my settings are on this. This is correct because what you want is about the 1/10 of the diameter of the bit, which our bit is 3/8 of an inch, right? Let me double check. Oh, it kept my 1/8 of an inch step over. That's interesting. Okay, I didn't have my correct bit selected, so I got to put this in by hand now. Okay. So if you take the size of your bit, which is 3/8 of an inch, it's 0.375, and you divide it by 10, okay? We're going to do 1/10 of the diameter of it, should be your maximum step over. Typically that will come in for you. Hit OK. Now that is set up correctly, and it takes about 22 minutes. My 1/8 of an inch, if it was going faster than that, I might not have had that step over set correctly, okay? But that's why. And so notice when you change a parameter like that, it dramatically changes the amount of time. It also changes the paths, the number of times it goes around, all that good stuff changes based on just one simple parameter, okay? All right. So we're using our 3/8 inch. We make a tool change from our boring operation to our pocketing and then to our contour. Our contour is the final operation, and it goes around, and notice it just leaves this. Now here's what's interesting about it too, is it kind of digs into it and digs out of it right here. You may or may not want that, and you can set that. You can change some of the settings for that. I'm not as familiar with that, so I'd have to play around with it just a little bit. Ooh. But it's how it goes in, the lead in and the lead out, and how it does that. You would have to change some of those parameters to change how much it bites in and out of, and let me look at this again right here. This little chunk that it bites in and out of, you can change that by changing some of those lead in and lead out parameters, okay? I'm not gonna do that right now. It's probably fine the way it is. It's not that big a deal, but that's how you would change it. Okay. Another thing to notice in this, notice this, it gets done with it and it didn't go perfectly into the corner there. Notice also over here, it did not go perfectly into the corner, okay? That's okay. That's because of our bit, the diameter of our bit, okay? It can't go further into a corner because it's a round bit. It's going to leave a rounded corner here, all right? Now, there are some tips and tricks for doing it, and we would actually, like if we have something that has to be set all the way into the corner and we are dependent on it being perfectly into the corner, I'll demonstrate that in a different video. We actually have to do something different in our CAD drawing to do that, okay? So that's basically it, okay? Everything else, that I've demonstrated here, you would just apply to the remaining areas. And again, I wouldn't take out these smaller areas. I would go ahead and leave them and just take out the big ones and go from there.